Hello everyone, welcome to Krishna's online lectures. In this video, I'm going to discuss concepts of friction and friction force. So as we know, friction is important topic of physics and friction is related to motion or motion between two bodies. So we can say it is related to relative motion. So when relative motion is present, at that point we always consider friction and friction force. Relative motion between two bodies. That body can be one stationary body and one body which is in motion, and other condition when two bodies are in motion. So where relative motion is present, friction is present there. And if we consider relative motion, so relative motion we always define because of external load. So here, if you can see this particular diagram, so here we are considering one body, and this body is placed on one stationary surface. So this surface, if we consider as stationary surface, so here this body is placed on stationary body or stationary surface. So this stationary body we are considering as body 1, and this body we are considering as body 2. Now when there is no force applicable on this body 2, so here we will consider two forces. One is the weight that is acting vertically downward, and another is the reaction which is opposite to the weight. So here weight will act vertically downward, and opposite to this weight we will consider reaction that will act vertically upward. So this is basic free body diagram of this body or for this condition. Now if we are considering relative motion between these two bodies, so here we have to apply one external load on this moving body. This body 1 is the stationary body, and this body 2 can move after application of external load. So if we are applying external force F on this body in this direction, in that case this body will try to move in the direction of force. So this particular arrow is representing the direction of force. Now if this body is in stationary condition only after application of external load, so that is happening because of one resisting force which is applicable by this stationary surface. So when this body is moving in this direction, or if it is trying to move in this direction after application of external load, so there is one resisting force applied over this contact surface by this stationary body or by this stationary surface, and that force will act tangentially over this contact surface. So that tangential load which is acting at the contact surface is called resisting force, and that resisting force is called friction force. So this condition we are considering when one body is stable and one body is in motion, and this motion we generally define because of the magnitude of friction force. So here first I will define the friction. What is friction or what is friction force? So if we are considering two bodies where one body is stationary and another is in motion, so the force exerted by the stationary body on the moving body at the contact surface is called friction force. This is called friction force. So here this resisting force, this particular resisting force against the external load which is applicable on body 2 is called the friction force. So friction force always act opposite to the direction of motion or opposite to the direction of external force, and it will always act tangential to the contact surface. So this resisting force we consider as the friction force, we can also say it act opposite to the direction of motion of the body, and it will act tangentially at this contact surface only. We cannot consider this friction force at this surface opposite to the direction of force or opposite to the direction of motion. This friction force will always act tangentially at the contact surface only. So this is our first condition when one body is stationary and another body is in motion. Now, if we are considering two bodies which are in motion, so let us consider two bodies, body A and body B. So this is our body A and this is our body B, and there is a relative motion between these two bodies. Now here, after application of external load, when this body A is moving in this particular direction, so this is the direction of motion, or this is the direction of force for body A. Now here, two bodies are in contact. So this particular body A is in contact with body B. So this particular surface is the contact surface. So to resist the motion of body A, there will be resistance force applicable by body B over this contact surface, along this contact surface or tangential to this surface, but it will act in opposite to the direction of motion or opposite to the direction of force. So here, this particular load we will consider as friction force, which is applied by body B on body A for resisting the motion of body A. Now, this body A is moving in this direction. Now what will happen? Now let us consider body B as the reference. So here body B is moving in this direction. So in that case, this body A will also apply resistance force on body B at the same contact surface but in opposite direction. So here, this particular load we will consider as friction force, which is applied by body A on body B against the direction of motion of the body. So here, this particular force we will consider friction force applied by body B with respect to body A, and this force we will consider friction force applied by body A with respect to body B. So here, this friction force is acting in pair, and this condition we will consider when two bodies are involved and there is a relative motion of two bodies we are considering. So when two bodies and both the bodies are in motion, so this friction force will act in pair. This FAB and FBA will act on the contact surface only. But when one body is stationary and one body is in motion, so there is one friction force will act, which is applied by the stationary body, and it will act opposite to the direction of motion or direction of the external force. Now here, these two bodies are in motion. Now when this body B is resting on one stationary surface, so what will happen? Against the direction of motion of body B, there will be, for example, if body B is moving in this direction after application of external load or because of some load, so friction force will act or it will applied by the stationary surface opposite to the direction of motion. So here friction force will act here. So let us consider F friction. So this particular direction is representing the direction of friction force which is applied by this stationary surface on body B. So here these two conditions are representing the friction force, and this friction force is representing the relative motion between two bodies. And how we can define friction force? So friction force we consider as the force which is applied by one body on another body during the motion, and that force always act at the contact surface. This general condition is representing when one body is stationary and one body is moving. So stationary body will always exert friction force on the moving body opposite to the direction of friction, opposite to the direction of external force, and it will act tangential to the contact surface. So this is the basic definition. Now if we talk about the motion of body, so motion is generally defined by the friction force only. Here we are considering two bodies. One body is stationary and another body is in motion. So here we are considering two body 1 and body 2. So this body 1 is stationary body and body 2 is in motion. It can be in motion. So if we are applying one external load F in a particular direction, so what will happen? After application of this external load, this body will try to move in this direction. But when the body is in stable condition. So what will happen here? The stable condition we can only define because of the friction force applied by the stationary body. So when we apply external load, so against this external load, there will be one resistance force offered by the stationary body on the moving body at the contact surface, and it will act tangentially. So this direction is representing the direction of friction force. Now, how we can define the motion of this body, body 2, with respect to body A? This motion is only possible. For example, if we have magnitude F. So if F is equals to friction force, if this F is equals to friction force, in that case, what will happen? Whatever force we are applying, that equal magnitude force is applied by the stationary body on this body too. So both the force will nullify the motion of the body. So this body will be in stationary condition. So for motion, this friction force should be less than the applied force. If the friction force is less than the applied force, in that case only this body will move in the direction of external load or in this direction of motion. When this friction force is equals to applied force, in that case this body will be in stable condition. But when this friction force is greater than the applied force, so body will move in opposite direction. So wherever force is more, in that direction only body will move. So by this way we can define the motion of the body or direction of motion of the body, and this condition is applicable on when bodies are in motion. When both the bodies are in motion, in that case these conditions are applicable also. So for both the condition, when one body is stationary and one is movable, and the second condition when both the bodies are in motion, so these two conditions are representing the actual motion of the body. Now friction we consider everywhere where motion is present. So for example, we can say in machines, there are a lot of parts which are in motion in machine. So at every place where motion is involved, there we consider friction. For example, bearings, for example, gears, in pipes, whatever kind of flow it is, either it is water or it is oil or some lubricant. So where the fluid is flowing inside the pipe, so the friction is present between the fluid and the solid surface of the pipe. That is also considered as the condition of friction. In bearing, we consider friction. Power screws are the example of the friction where friction is present. So there are some example which is related to friction. So we know friction is present where motion is involved. So friction is mainly responsible for loss of power. It can cause wear and tear of the parts. So basically it is representing the economic loss because of the motion. Here if we are considering two surfaces which are in contact, so when this body is in moving over another surface, so what will happen? This body, the contact surface, can wear out because of the applied force and because of the resisting force. So this wear of surface is representing the loss of power, or it representing the economic loss. So basically friction is represented as the force for the loss, but friction is always necessary for the motion. We cannot define any motion without friction. So friction is always necessary, but it depends on the applied force. Whatever friction we require, it depends on the applied force. So friction is present everywhere, but in considerable extent in every kind of machine, but it is available in considerable extent. So friction is also a necessary force which is required for the moving parts or moving bodies. So in machines like belt and rope drive, we can also consider friction in the brakes when brakes apply. So that brake is mainly going to stop a particular machine, or for example in automobile, when we apply brakes, so that automobile is going to stop. So the assembly of brake are based on the friction, and that vehicle is also stopped because of the friction of the tires and the road. So at that point we consider friction. We can consider friction in clutches. So wherever motion is present, friction is always present. So friction is advantageous somewhere, and as well as it will disadvantageous somewhere. So 50-50 situation we can consider for this. So at some part friction is having some disadvantage, and some part friction is having some advantage, but without friction we cannot consider motion. Now let's discuss a quick description of types of friction. So basically friction is defined by two types. One is the dry friction and another is the fluid friction. So we define dry friction. So dry friction is represented when the contact surface are dry. When two surfaces which are in contact, and this particular contact surface is dry, and both the bodies are representing motion. So where at this particular condition we consider dry friction. So basically it is representing the condition of the contact surface. Now it is divided into two parts: sliding friction and rolling friction, and this friction is depends on the motion or exact motion between two bodies. So sliding friction is representing when two bodies are having sliding contact, or when one surface is sliding on another. So that particular, and the friction which is present between the surface or at the contact surface is representing the sliding friction. Now second one is rolling friction. So this is also representing the motion between two bodies. So when contact surface are in line contact or are in point contact, or one surface is rolling over another. Basically rolling motion is representing the condition of friction, rolling friction. So when there is a rolling motion present between the surface and the surfaces are dry, so that is considered as rolling dry friction. So at that point contact between the surface should be line contact, or it can be point contact. So it can considered as a higher pair, but this sliding friction we can consider as lower pair friction, or the pair should be, when we are considering two bodies, so the pair should be lower pair. So this particular friction is applicable on lower pair, and this particular friction is applicable on higher pair in terms of kinematics of machinery. A second one is fluid friction. So fluid friction we can define on the basis of the contact surface, nature of contact surface. If contact surface are separated by a film of lubricant, so at that condition we can define fluid friction, and the motion we can define on the basis of fluid friction. Now it is also divided into two parts: non-viscous and viscous. So non-viscous is representing the viscosity of the fluid which is present between two contact surface. So if very thin layer is present, or if very thin layer of lubricant is present between the surface, so at that condition we will consider non-viscous friction. And when very thick layer of lubricant present between the surface, so at that point we consider viscous friction. Now let's discuss main type of friction, that is static friction and dynamic friction. So the static friction and dynamic friction are representing the actual motion or actual condition of motion or actual relative motion between two bodies or two surfaces. So static friction means when there is no motion between two bodies, and we can also define this particular friction when there is tendency of motion is going to happen, or tend to move condition is going to happen. If this condition we are considering, so at that point we can consider static friction. So when friction force is present between the contact surface, and this condition is when there is no relative motion present between the surface, so that particular friction we define as a static friction. So static friction we can define the friction force between the contact surface when there is no relative motion between the surface, or when the motion is tend to happen, the motion is tend to happen, that particular condition representing the static friction condition. And we can also define this condition in terms of external force. when there is no external force present, so body will be in stable condition, and between the contact surface or between two bodies at contact surface we can define static friction. Now second one is dynamic friction. So dynamic friction we can define, it is based on the dynamic motion or it is based on the condition of motion. So when friction force between the contact surface is present, when there is relative motion present between the surface, when relative motion present between the surface and friction is present at the contact point or at the contact surface, so that friction is representing the dynamic friction. Here you can see two bodies and both the bodies are in contact. So not always these contact surfaces are smooth. These contact surfaces have irregularities. So when two bodies which are having smooth contact surface, so at that point friction will be negligible. But when irregularity is present, so at that point we can define the amount of friction between the contact surface, and these irregularities are defining the contact between two bodies. Contact will be more when more irregularities are present between the bodies. So here these irregularities are defining the actual friction force after application of external load. So when one body is subjected to external load P in a particular direction, so this second body will offer one resistance force, that is frictional force, over these irregular surfaces or over this particular contact surface, but it is in opposite direction. So at this particular surface we will consider friction force, and this force, as I told you, it will always act tangential to the contact surface and it will be opposite in direction of motion. So this is all about friction. Thank you for watching this video. You can rate, review and share this lesson with your friends and your known people. And if you want to watch more lessons related to mechanical engineering, please subscribe the channel.